Hello, and thank you for joining us for this latest AMS webinar with our partner SICK Sensor Intelligence. My name is Simon Duval-Smith, and I am the Associate Editor of Automotive Manufacturing Solutions, AMS. This morning's, or today's webinar is dealing with the total integration of product identification used in automotive production processes. This is a dream of many, many industry leaders, line engineers, and manufacturing engineers. RFID-based identification of car body, which we refer to as body ID. With this, it's already possible to integrate and harmonise tracking and tracing for mainline in car production. Our webinar today is going to demonstrate how integrated identification can be realized from the body shop right through to paint shop to assembly shop and beyond. It's being brought to us by two experts from SICK, Michael Fislager and Andre Hack. Michael's been head of the SICK product unit RFID since 2005. Before this, he was several years in R&D and marketing and sales for RFID company, followed by 5 years at Atmel Semiconductor. So he has more than 20 years of experience in this technology and is a diploma engineer graduate in industrial electronics. On the operational side, Andre Hack has been head of the automotive industry segment for SICK in Asia since 2009. Andre has broad international automotive experience, being department manager for production engineering at EDAG in Japan for 3 years, and before that at FFT EDAG as project manager for car body production manufacturing solutions. And he's a diploma of engineering, of course. Before I pass over to them, could I remind all of you in attendance to think of some questions and write them down, which Andre and Michael will answer in the Q&A session following the presentation. Please ask the questions by typing them into the box on the lower right-hand side of your screen. If you have any technical issues during the session, please also type these into the Q&A box on the right-hand side of the screen, and we'll sort them out. We hope you'll find this webinar stimulating and informative. I'll now hand over to Andre Hack and Michael Fislager for the presentation.
So, ladies and gentlemen, good morning, good afternoon. My name is Andre Hack, as Simon has introduced me. Thank you very much for this, Simon. We're very happy to be part of this webinar series and to introduce you today the topic of RFID-based car body identification. I'm your co-presenter together with my colleague Michael, who I let introduce himself first.
Okay. Good morning or good afternoon, depending on where you are from my side as well. As I said before, my name is Michael Fislager, and Andre and me will manage the session today with you.
Thank you very much. I changed to the presentation now. As Simon said, please note down your questions. We will have after the session a Q&A to give you replies to ideas you might have during our presentation. I hope you enjoyed, and I hope we managed to have a good discussion on this topic afterwards. So, I hope you can all see the presentation screen now. Changing now to the main presentation. So this takes some time. Okay, this should work. So, as Simon introduced, innovative car body identification based on RFID technology, the topic of today's webinar. This is a technology for the past 2 years successfully at various different customers, and looking forward for the next 45 minutes together with you. A few words to SICK. We've been a partner for the automotive industry for the past of more than 65 years, one of the pioneers in the automation and sensor field in general. Today we're a leading global supplier of sensors for different industries and different segments. Last year we reached a turnover of more than 900 million euro with a global workforce of more than 6,000 people based in 86 countries. Maybe you have ever wondered why the company is called SICK. This is due to the gentleman on the lower right side of the slide. This is Mr. Erwin Sick, who founded the company and followed or was the head of the company for the first until it was taken over by management staff. To the topic. Currently, the automotive industry for the past faces a lot of challenges which lead to increased need for product identification in car production. First of all, we've reached a very high level of complexity inside of car assembly, car production, with increased number of parts and growing number of models per line. A lot of car manufacturers are already running more than 8 different models on one line. Therefore, complexity with the increased number of parts is already at a very high level and tends to further grow. Besides this, we have the topic of managing this flexibly. It's build-to-order customization. Basically, the production volume or lot size one different production after, or like just in sequence production, which requires highest level of flexibility. Besides this, the external factors are managing the supplier network integration, integrate tier suppliers that component suppliers are outsourced to externally, also internal supply companies over corporate sourcing networks, and part of this also anti-counterfeit strategies to ensure that the products that end up in the car are the ones that are supposed to be there, and not counterfeit products from different parties. Besides this, as a general technology trend, the level of automation in the industry view will further grow, and we have also trends for centralized production control. These 4 main points are major drivers for the technology to increase the product identification within the car production. Going to this slide. As a result of this, the dream of a lot of heads in the industry is total integration of identification processes throughout the process. When we see car manufacturing here, we can see the main production line of a car manufacturer with several supply structures or supply processes. The total integration, being able to integrate all the track and trace ID processes here, is the target or the dream of the industry. Compared to the current situation, this looks slightly different. So today, the reality is that we do have a high number of diversified technologies and systems fulfilling the track and trace applications in automotive manufacturing. In the view here, it's a slightly different viewpoint angle, but this is the present situation, that every single shop, or sometimes even within the shop, there are different technologies in use, different interfaces where parts need to be copied and risks being created. So at all these interfaces that we marked here with red, we have potential risk of data loss, of data transfer errors, and of course with running a series of different databases, a series of different IT systems, as well as the track and trace technologies itself. Yeah, a high interfacing cost and a high process cost. And the target of total integration is aimed to reduce this risk, reduce the cost, and by this also have several further benefits in terms of transparent tracking and yeah, real-time product identification. The first approach that is now possible to to get closer to this total integration, car body tracking throughout the process. This is the main topic for today. Is now possible with the technology based on RFID. So, but first of all, why is this possible now? Why was this not possible in the past in this way? When we have a closer look at the main three parts of the body process, starting on the upper left hand and the body shop, through the paint shop and chassis final assembly, we had in the body shop usually optical recognition systems like barcode to decode, but also already HF RFID for example for skid tracking, to bring the parts on the line or to track the skids or the pallet on the line, with superior MES systems to identify which body is currently in production. Then we have a classic interface towards the paint shop, where we have experienced different solutions, sometimes also RFID solutions with active transponders that are mounted to the car body, but sometimes also rigid, robust optical barcode or to decode ID systems on laser-cutted steel plates that can be recognized by optical barcode readers or camera systems. And then the second classic interface here towards TCF, final assembly, where we usually also see optical systems, barcode to decode, or the VIN number reading with OCR. These are the classic points. Different solutions are used, often also evolved structures in every shop, as every shop has its own tradition, has its own responsibilities, its own ownership about the production inside the shops. And due to this, we have these interfaces where transfer of data, copying is required at multiple points, and as said before, where risks may arise or definitely are arising, this is combined with high cost when you have a close look to this. In the past, this concept of an integrated ID system, which would replace this into one, usually or often failed because of the physical requirements in the paint process. And now we're showing you how we were able to overcome this in a technological way. UHF RFID technology, passive technology, made this possible in a process view to integrate the process from the body shop production through the paint shop production, final assembly, even to be used later on also in the logistics process. And yeah, by this we have reached this level of integration already at this process. The detailed requirements that we have, we were able to solve are in the coming slide. What are the technical needs of this application? First of all, we're facing very rough environmental conditions in the body shop, which requires robust and reliable reading devices. In the second step, we have the main limitation here in the paint shop with very aggressive chemicals and high temperature. Therefore, we need to have high temperature proof and durable transponder labels. And besides this, as a general topic, we have the requirements for integration, that network integration of this solution can be compliant with the general automotive requirements to be retrofit into existing systems, but also be able to meet the demands of the most modern concepts and technologies. At this point, I hand over to Michael to give us a detailed view about how the solution that we have looks like.
Thanks, Andre. Okay. We at SICK, we developed the product with the name RFID-based to especially address the application and customer requirements for car body identification. What was very important for us right from the beginning to choose a technology that is standard compliant. Therefore, the customers do have the advantage for a long time availability. Within the reader firmware, we implemented features that ensure highest read rates in configurations where the car body is in motion or halt position. Both application conditions could happen here. Furthermore, this is supported via the unique homogeneous field distribution and reflective power management of the reader antenna. The output power can be adjusted, and it gives the option to find the right setup for different operation distances. Also, the reader can address distances of several meters. In typical applications, we have normally read and write distances of 1.5 meters. To reduce the installation efforts, SICK decided to combine an antenna and an electronic in one compact design. If there is a use or a need for further antennas, up to 3 external antennas could be connected. Due to the strong requirements, especially in the body shop, SICK decided to use a robust metal case housing with IP67 protection class. Here you see some pictures where typical reader installations are available, so it could be on site, could be sometimes from the top or sometimes from the center to the out. In addition to a good reader, we, as Andre mentioned before, we need also the best transponder that match to the requirements and especially survives the production process. Within a typical paint shop, we have high temperatures with peaks up to 230 degrees Celsius. And this label is designed to withstand the stress. With an extensive test phase, we also proved that the communication link between the reader and the transponder work under this strong EMC environment. In existing installations, the label already proved that it's robust and durable. Users reported that existing solutions do have relative costs between 3 to 5 euro per car. This label, with a cost of less than €1, will bring the benefit of additional cost savings. The next important topic is the network integration. We have normally on customer sites central or decentralized systems. But mostly we have a PLC environment with then the common feedback interfaces. Therefore, SICK to have the need for all Auto ID components that could be barcode, 2D or RFID, to address the common interfaces with one platform. We call this the ID Pro platform. The RFID 630 therefore do have an integrated Ethernet interface like a TCP/IP or Profinet I/O or Ethernet IP. To make the integration as easy as possible for the user, SIG provides for most common PLCs functional blocks for transponder read and write operations. Depending on customer needs, results could be extended with diagnostic information, or additional data streams could be generated that will be used for preventive diagnostic only. All SIG components could be parameterized with one graphic user interface. We call it SOPAS. Other interfaces are supported as well, so sometimes we have existing installations that need to be addressed that could have the requirement for an RS-845, 485, 422 or 232 interface. With additional gateways, we also could address DeviceNet or older interfaces. The RFID 630 is installed and in use already at several users. Today we do refer to an installation at Mercedes-Benz. Here we have an installation running since nearly now 1 year. We have already proved high read rates and write rates under very critical environments. Within the photo you can find the label that is fixed here at the front beam of the car body. Please have a look to the red cycle. In the picture in the middle, you can't find the reader. You need to know that the reader here is mounted and under the plastic plate, again in the red cycle, and reading the text from the middle to the out. The next installation in the assembly shop is at Ford. Here we have already an installation since August last year. There are several points we need to address. On the top left picture you can see a reader that is looking from the top down to a transponder that is attached to the backside window of the car. In a second application here, we have several readers installed from the top again, reading cars that are waiting for an inspection check. One challenge here is that cars are very often not guided and we have not a trigger at all, so the reader must manage this changed situations.
So, now it's Andre again. Thank you, Michael, for this very technical part regarding the solution that we have from my side, the industry view. We also want to give a look ahead. What are the next steps following this first approach that is already possible and used at several, quite a high number of our customers. The two references that we've shown from Daimler and from Ford are just the two ones that we have official approval to share. So there are quite a few others who have already integrated the solution throughout the process, some even beyond the manufacturing into the logistics. But the next step of this process that we are also already doing with one particular customer from ours at the moment is unification of the chassis production process and the car body tracking process. This is like an almost logic combination because both processes merging together in like the marriage process or the decking area as called where the chassis and the body are merged together. If these both processes can be tracked inside their own line with UHF RFID technology, this can be very easily be integrated into one common process in these two lines. This, as said, is already done at one customer of ours and is definitely a logical extension trend of this technology. The second step that we see is also quite logical and already feasible, which would be the integration or incorporation of safety relevant components, which already from their suppliers or the manufacturers often come with UHF RFID transponders as part of the components themselves to ensure the safe identification of these components within the tier supplier's manufacturing, and this can be integrated into the tracking process with the same technical solution and readers. These two steps are, in our view, the next logical part to the step or the dream of total integration. But when we have a look at the central chart again, all the other processes, powertrain, supply components, tier supplier integration can be easily done with this technology and are tried, tested in the industry as well as part of several research programs in different countries. So we're very sure that this technology will drive total integration to a completely new level. As a summary for this process, your benefits as a user, in our view, the main four are the following. First of all, it's a huge potential for cost saving as you're able to eliminate these high number of process interfaces. Like as Michael said before in his part, we did several return of invest calculations with our customers where they identified that these processes of interfaces, running different databases, doing data transfer are very costly. There are numbers ranging from, in euro terms, from 4 to even higher volumes of euro per car. And with this technology of like less than €1, you can save at least, from our current viewpoint, at least €3 per car, probably even more, combined with several other benefits. First of all, transparency. Now you're able to place the identification directly to the product. So that the transponder, the RFID transponder, placed at the product, not placed at the skid or like another carrier of the part that is supposed to be tracked. It's directly at the product itself, and therefore allows a different or a lot higher level of transparency, and therefore being able to do this total integration. Flexibility. With this technology, you're able to read and also to write information to the transponders in each station. So it's possible to flexibly change information, and it's also possible to add information, to give data, safety data, or data which are relevant for the processes, to give this along with the product to the following stations. These functions are optional, so it can be done, but it can also be very safely and cheat-proof be used as just a serial number where only reading is possible in the process. This is based on the customer's or the user's process. Performance and simplicity. From our experience of the past installation as well as tests, we have realized that this technology offers the highest read rates In the installation that we did at Daimler, this is higher read rate than we were able to achieve with optical reading technologies, camera systems, or barcode reading systems. Besides this, with the flexible reading distances and with a very strong data acquisition field or the reading coil, it is very, very easy to retrofit. So for installed applications, existing lines, this technology offers a very simple and very reliable way to retrofit systems into existing production. With this summary, we would like to come to the Q&A part. As said, we hope you made some notes to ask questions, and I will hand over now to Simon to host the Q&A session. Thank you very much.
Thank you as well.
Thank you, Andre. Thank you, Michael. And thank you very much for showing us the case studies, the actual applications of the technology. This is always, I think, most interesting for our audience. I've had a couple of questions come in by email myself, and I'm sure we have one here from Neha Ver. Oh, sorry, can I get your full name? Sorry, Neha Verma. I don't know which company you're from. Perhaps you could tell us, or you can keep it secret. I don't mind. Can you tell us what? This is a question I was going to ask also. The temperature cycle that the transponder can withstand, and I think that Neha here is asking really about paint shop cycles and about heat cycling. Can you tell us about that, Michael or Andre?
Yeah, we can. We have done several tests with our customers. Basically, such a transponder label is designed to withstand at minimum 1 cycle. After that, it's normally wasted. In our testing, we have been able to prove that a tag could survive roughly up to 10 cycles and is still functional. Yeah, but that's not the target. The target is one-time use.
Yeah, basically the technology is designed to have the transponder together with the body for the process, one-time use, and the real or the additional benefit can be achieved when the transponder is also used for the logistics processes. That means the transponder stays with the body at a cost of significantly less than €1 per transponder. This was usually referred to from our customers and the end users as absolutely acceptable compared to the cost saving to other technologies.
Thank you. Another question there from Salman Fahim. How do you mount the label on the car body? And I think you've answered some of it about how they're reusable. But in situations, I mean, obviously we're trying to avoid changing labels as we go down the line. But in situations where a label is used in a non-hostile environment, is it reusable? And again, then how do you typically mount it?
Yeah, the mounting of a transponder at the car body, that's one of the main topics that need to be discussed with the customer. Several parties must be involved, from the paint shop and from a quality department as well. Normally a label position must be defined that over the complete process is somehow electrical visible. So for sure you can't mount a metal part direct in front of a label. You can't read through metal. So that's one of the main jobs that need to be done right from the beginning to find the right position and make the right bracket to mount this label to the car body.
Yeah, this is the key is for this process to involve the car development people themselves to find a spot in the car where the transponder can stay from the body shop until the end of the manufacturing. Relocation of the tag is also a practice that we are doing with some of the end users, that the tag stays on at the same position from the body shop throughout the paint shop, and then for the final assembly will be relocated. This is possible, but of course in a optimized process, we would recommend for new car development to find a spot where this transponder can stay on. And I think for your second question, of course, when you integrate this technology inside, not through the whole process of the body, but inside of a non-hostile environment, of course, transponders can be reused. The limiting factor for the transponders is indeed the heat here, the heat and the chemicals, where it is sure that the transponder will withstand or survive one process. Yeah, for non-hostile environments, this is reusable.
Thank you. Thank you. I have a question here from Giancarlo Lerda. He's saying, in your opinion, who's the best contact in car manufacturing for this solution? Would you deal with the IT department, or would you deal with the manufacturing engineers? I mean, who is your first point of contact, for instance? There might be a competitor here asking how to market his product, Andre. I'm not sure.
No, this is a good question. Like the point that we're here at is that we're with the process that we've shown. When you want to integrate the complete process from body shop to the logistics area, then it's usually, from our experiences, at a responsibility which is beyond or above the responsibilities of the single shop. So very often IT or shop floor IT, central IT departments need to be involved or contacted for this as well. And this is like from a corporate view or from a complete factory view, the benefits are the most obvious or the biggest ones to be seen. And therefore it shall be, I think, together with the user and approach to bring all the related people into one boat, the people from the body shop, from the paint shop, from the assembly, together with people from the central process control IT department to discuss this topic together. And this is, from our experience, the point where we see where the realization of the benefit is then easily made clear or understood.
All right, thank you. Thank you. We had a question from somebody I think is Mr. Ram Gupta, and I think it's pertaining to the length of time and how long the transponder would stay on the body. Will it go into the logistics pool situation? Because as you've seen from some other presentations that were recently at the AMS South America conference, the situations where vehicles that are finished and destined for rework or destined to go straight out to a dealer go the wrong route. I think what Mr. Ram Gupta is asking is how long can it possibly stay on there for logistics purposes?
Yeah, so it depends for sure on the position where the transponder is placed. We have users where the transponder is based right behind the bumper, and then it is very safe there. It could be used for logistic applications as well, and due to the fact that it stays there, it could be used for a very long time here, also for after-sales purposes.
I think to add one point here, another benefit when you talk about logistics, or when you talk about the processes that directly after the line, also already in testing, checking the different test runs that vehicles do, the benefit here is that at this point the cars have left the line. So line tracking isn't possible anymore, and with this technology, when you have a transponder on the car, you can easily track them within, like, let's say, more chaotic movements, and not organized movements within the line. Even, yeah, as Michael said, throughout the shipment to the car dealer, yard management, the complete process.
Thank you. Thank you. I think we've got an inquiry here, actually, Andre, from Mr. Kore Tokol. I think maybe from Turkey. I'm not sure. Maybe from a famous car maker in Turkey. Can we use this system in an assembly shop where we have a car body proceeding in assembly, but its production volumes are low? So he's saying that in order for a manual operator not to miss an assembly operation to be done on this type of car, how can we recognize the car body? So I think he's saying that how easy is it going to be to integrate manual process into automatic process? Are we going to have to use a manual reader, or are you going to have maybe a signal screen that comes up to identify the vehicle, where you have low and varied production, I think?
Yeah. So for this technology, there are handheld readers available in the market. Due to the fact that the transponder we have implemented in this kind of application is standard compliant, there are a couple of choices. We as SICK can also supply readers there, so it's really easy for a user to find the right handheld to do this.
So yeah, there are handheld devices available also to integrate this into manual processes. Absolutely.
Very often, if customers or users do have handhelds, these special handhelds do have the option that you can combine with that, let's say, state-of-the-art reader engine with that on top.
Thank you. I'm sure that you can expand on this explanation with Kore Tokol, and you will get all the information later to speak to everybody. A question another from Neha Verma. What is the memory of the transponder? I presume this is the memory capacity that they're asking about. Is this relevant, really?
Yeah, let's say for sure it's important, the memory here, and depending on how much information the customer and user would like to write on such a transponder, and also on the concept if it's centralized or decentralized data management. Standard sheet labels do offer a memory of 240-bit plus 512-bit. That means in total roughly 800 bits that could be used. In case more memory is required, then normally it could not, so today, up to today, could not be offered in a label. Then we need to go to an hardtag. That's more costly. But here we have several kilobits that could be offered as memory capacity in a transponder.
Thank you. Thank you. I have an inquiry here of how do we contact SICK in India? Do you have an office in India, or do you deal with dealers, or can I get details of the dealers in India? This is from Mr. Sanjay Bhatt, B-H-A-T. So Sanjay, I would suggest certainly that you attend the AMS India Manufacturing Conference in Pune from the 3 to 5 December, where Andre Hack will be delighted to help you with any challenges that you have. And I'm sure that Andre will be in touch, and Michael will be in touch after this webinar as well, Sanjay. So thank you for your inquiry. Can I ask also from Eugene Lawrence, are there any plans to brand the tags with reference to SICK to ensure that a pirate is not used? It's interesting that this technology is to help avoid piracy of components and so on in vehicles, but what about the branding of them? Is this relevant?
No. Don't see any need to brand this label so far.
Okay. No, thank you. I've got one here. Is there any manufacturer who uses your transponders even up to service? From Dharmesh Patel. I presume that means that there's the idea that the transponder could remain on the vehicle in its service life. Is this too outlandish a suggestion, or could it be the future?
Yeah, there is one user where the check remain behind the bumper, and As we know, he is also using this afterwards for services, but that's under his own control, so it's only the information we have. It's not something that we have somehow influenced.
Yes, it's definitely possible. Like Michael said, behind the bumper, so reading through plastic is possible. Transponder at a safe place. It can be used, and as far as we know, this user is intending to do so, to use it also for servicing and use it at least for the distribution, but we don't have too detailed information based on what they do afterwards.
Thank you. Thank you. Sanjay Bhatt also asked the maximum sensing distance of the label, and maybe combine this with another question. Is it necessary to use a SICK reader for a SICK transponder, or is it compatible? That sounds like it shouldn't be from a commercial point of view, but so there so maximum sensing distance and the necessity to use a SICK brand reader, please.
So first of all, the operation distance could be several meters, but depending on the application environments, this should be limited to what is really needed and not what could be achieved maximum. So we need to, let's say, assign the transponder to the right body, and here we need to find the right setup to do so. But up to 1.5 meter, maybe 2 meter in a typical application could be addressed. And in case you are not in a production line, you are made in a logistic process where you need to identify cars crossing a special point, then we can extend the read distance to 4 to 5 meters typically. In regards to interoperability, as mentioned before, we address an open standard called 18006C that is EPC global compliant as well. Every reader on the market that complies to the standard could read the labels, and as well the other way around, we can read every tag in the market that complies to the standard. And in combination with the handheld, that makes it easy, because if a customer, for example, to have a special handheld available already with a standard interface, he can buy also here for his existing infrastructure a module that he can plug in, and with that he can then manage the transponder reading and writing as well.
Thank you. Thank you. The transponder, I think that Salman Fahim was not entirely clear about the power source of the transponder. Could you very quickly run us through the self-powered, the reactive and non-reactive types, please?
Okay, from a technical point of view, we call it a passive transponder. That means the transponder do not have an own power source, so he is supported with energy out of the field that is generated by the reader. And the transponder itself, then we call it backscatter technology, is reflecting a part of the energy back. So while doing so, we have a forward and a return link. All transponders in the field will not start talking without a request. We call it reader talks first. And while doing so, it is also possible to manage a population of tags that are at the same time present in a field. So we call it as well anti-collision. So up to several hundred of transponders could be simultaneously detected, but in this kind of application, for sure, the aim is to find the right one, and that's for sure what we need to do.
Thank you. Thank you. A lot of inquiries from India here, from Neha Verma. Do you have any reference installation in India, like a case study in India? Perhaps something that you'll be showing at the AMS India conference?
Well, of course, like as you said, we will be together with our colleagues from SIG India at the AMS conference to talk more closely on this topic. At the moment, the present situation is that we are in India in contact with several users, and especially the users that are using the technology in other countries also want to integrate it into their manufacturing in India. So we're discussing several implementations of the technology also in India, but at the moment there's no reference application running in India itself with this total based on this concept. Like we do have RFID applications running in India, but not for this body ID concept yet.
Thank you. So I think that's a good opportunity for Mr. Nehal Verma to invite you to perhaps do a small installation to demonstrate this on a car body ID in India. I've had a question from a Damesh Patel. Are there any side effects on humans of a radio frequency field over a period of time? I mean, we're talking very, very low levels of radio frequency, aren't we? Generation and microwave energy compared to the general EMC that you find in a car plant. Well, I think that would be the right way of looking at it, wouldn't it?
Yes. What we also could tell on that is that RFID, UHF RFID, is the same frequency we use for our cell phones. So it's the same frequency and the same power. So everybody of us is using cell phones direct close to the head, to the brain, without having any, let's say, negative effect on that so far. And UHF is the same, as said before, same frequency and same power. So there's no effect known on human bodies.
Yeah, as you say, I thought the level of any microwave or radio frequency radiation, etc., was very, very low. I have a question here that was emailed in to me earlier about the RFU 630. The RFU 630, you might want to refer back to your presentation. What is unique in its application? Because you have talked about it as being a new unique tool.
Yeah. So yeah, the RFU 630 to have a lot of intelligence inside. That means depending on if we need to read it in movement or standstill, within the reader we have several algorithms and filters that we detect the right transponder. So as we have discussed before, we need to think about a lot of items around the car body that will have in the future own transponders. Those filters must be filtered out in case we have other text around, we need to do the right assignment, and all these, let's say, operations are done inside. So at the end of, let's say, the process, the customer will have a very safe information what transponder is in the field, and also the feedback that it was possible to read and write to this transponder. And because of that, we simply have a result that we generate for a PLC in case of giving raw data to a higher host system.
All right, thank you. Thank you. I was recently at a General Motors Europe van plant here in the UK, and they still, when they take the doors off after paint, when it comes into final assembly, they still mark up the doors by a handwritten paper label stuck onto the doors, so that they go off for dressing and come back and meet the same vehicle. How can your system integrate door dressing, door removal, dressing and return in a inline sequenced way? And I know that this would mesh with the normal inline sequencing, but is there an RFID tag tie-up situation with the removable part like doors?
Yeah, Simon, as we shown as a future opportunity with the chassis process. Technologically, it would be very, very easy to also integrate this into the doors. Like the doors also go to the paint shop. There it could be merged together with the transponder from the body when they usually go together on one skid into the paint process, or like side by side in one process. If this is not the case, if it goes separately into the paint process, then the best option would be probably also to attach one of these transponders onto the doors, and then with the capability of the reader, it can be merged into one set of data at the station where the parts come together, where the body meets the doors. With UHF RFID, this can be merged together in this one station to create the single set of data that would be required in this case.
Thank you. Thank you. I have a question, another question from Neha Verma. What's the time duration for which the transponder can withstand 230 degrees in the paint shop? Is there have you tested a time? You've obviously tested normal paint cycle times, but maybe he's thinking of some, I don't know, super durable paint that needs cooking for more than 20 minutes.
Yeah, no, as said before, a standard temperature cycle is 20-30 minutes, 200 to 230 degrees, something like that. That's where we focused on our testing. We have a test result from one user who left the label inside the oven for, I think, a complete night at 180 degrees, and the text arrived here. Yeah, but that's something we can't guarantee on that. But that's what we have seen.
So the specification basically is 230 degrees for several cycles of 30 minutes. This is like specification that we give with the transponder. From our testing experience, the transponder can withstand higher temperatures as well as longer duration. But we from our side, need to stick to the data sheet data. This is what we can make sure that this reliably works.
Thank you. And can I ask a question? I think it comes back a bit to like talking about the doors. Increasingly, we're seeing even more CKD and complex transcontinental, intercontinental assembly operations. I'm thinking, for instance, in India, Premier Auto have a CKD comes from China, which was a design that was made in Japan, the Daihatsu Terios. It's now shipped from China, and then they add an engine that comes from Italy, from Fiat, and they do this inside India. How global is SIC's coverage to think about perhaps putting RFID tags onto bodies or components in one country and then having them shipped and read so that there's a full traceability of components from one continent to another? Do you have that global spread at SIC to service your customers like this?
I start from the SIC view. I think we absolutely can support this technology and the installation service in like all the mentioned countries and all the major countries where the automotive industry has their production hubs and engineering hubs. I think from the technical viewpoint there are some points to add from Michael.
Yeah. So let's say for sure we need to address the regulations in the given countries, but the transponder itself that do have frequency behavior that it match. So it could be used globally. So as long as the transponder could be managed globally, and that's what we do with the design we have, we need to then ship to the given countries transponders that match to the radio requirements there.
So the basic thing is that we're facing here, as we're moving in the frequency band of cell phones. Basically, we have requirements and different radio requirements in different countries. So from our side, the hardware side of the reader, there would be different versions country by country, or like for different regions. From the transponders, which is the main case in this global sourcing strategy, this though would be feasible, possible.
Thank you. I have another question from Sanketh R. Saying, what is the data that's being communicated with the PLC? He's asking here if it's part correct, not correct. Can you just give us a simple idea of the kind of signal I/O in and out signal that's coming to this? And also, I wanted to ask you, when if an RFID transponder goes faulty, what signal does it give to the PLC, to the whole system? if the transponder itself is faulty? Can it give an incorrect signal, or does it just give a faulty signal?
Yeah, so we need to distinguish between the situation that could occur in an application. If we have a trigger to read a tag and the tag is completely dead, for sure we give a no read back. So that means for the operator, may the tag is dead or falling down. That may happen if the bracket is not designed in the right way. In case writing is not possible to the user memory, we can distinguish that. So we can say we have found the tag, but writing failed. So this diagnostic data is available as well. Or in case the transponder falls down, so that in a reading situation we have two transponders, and that could not be assigned, we can also put additional diagnostic data out telling I have found two tags. May your operator need to check if something falls down and need to be removed. So there are several options to do the right assignment, to give additional diagnostic data out. For example, we can say how often a tag was be able to be read in a given time period, or what signal strengths come back from a transponder. So that is, I think, a unique feature of our reader.
Thank you. And just the first part of that question, I think Mr. Sanketh R is trying to ask the data that's being communicated when everything's working properly. I mean, it's quite a complex ID data, isn't it? It's not just if the part is the correct one or not the correct one, or the body is this one or that one. There can be quite a lot of library of information in the transponder. Is that correct?
Yes.
Well, the user usually defines what kind of data is stored on the transponder. The most common process that we're building the systems on is to work with a serial number. So it's relatively similar to like a barcode or to whatever code, like one serial number per transponder, which then is related to the serial number or the production information of the body or of the components. And the information that you read out at the transponder then typically is this serial number. So the process for identification or for data management behind would be identical with the processes that you currently run when you do barcode identification or identification with other technologies.
Right, thank you. We don't have any more questions now, so I'm going to thank everybody very much for joining us today. We've had a good audience and some great questions there, and I think even a couple of strong, quite dare I say it, quite strong inquiries about Andre and Michael having to go and see some prospective customers there, which I think is exciting. And again, as I say, the next time that we will see the SICK company is at the AMS India conference in Pune, 3 to 5 December, and I'm sure Andre will be there and give a very exciting demonstration and presentation. I hope Michael will be there too. So the webinar that we've had today will be uploaded into our archives. Everybody can access that in the future and share it with your colleagues. Anybody that's been unable to log in this morning or today, depending on your region, you can access this and any other previous webinars, and we have a nice good library of webinar information, and you can find that under the Process tab on the AMS web homepage. So thank you again for joining us today. We'll hope you'll join us again for our next webinar, and thank you very much to Andre and Mikhail, and we hope to see you soon. Thank you.
Thank you.
Thank you too.